Hello and welcome to today's lesson, that is module number 2, lesson number 1 of module number 2. In the previous class, we have learnt about, we solved numerical problems based on the different basic terminologies and interrelationship between those terms and terminologies. In this class, in this lesson, we will be dealing with clay mineralogy, and we'll study about different type of soil structures like honey grained structure, honeycomb structure, single grained structure, honeycomb structure, flocculated structure, and dispersed structure. Before we start, I will just solve a couple of problems that was left in the previous class, and then we'll move to these topics. Okay. Write down the next question. It is the fifth problem. An undisturbed specimen of clay. An undisturbed specimen of clay was tested in a laboratory, and the following results were obtained. Weight of the soil is equal to 2.1 Newton. Oven dry weight equal to 1.75 Newton. Specific gravity of soil solids equal to 2.7 Newton. What was the total volume of original undisturbed specimen, assuming that the specimen was 50% saturated? So a specimen of clay is tested in laboratory. Its weight is taken. It is 2.1 Newton, and then the clay is kept in the oven. Uh, it is dried for 24 hours. Then the specimen is taken out and it is weighed again. Then that oven dry weight is 1.75 Newton. Specific gravity of solids equal to 2.7, and the specimen was 50% saturated. So degree of saturation is 50% or zero point 0.5. What was the total volume of original undisturbed specimen? So we have to find the volume of specimen. So originally soil sample is taken. Now this soil sample, it has both soil solids as well as water content. This is my specimen of clay. So they'll take the weight, and that weight is weight of the soil is 2.1 Newton. Next, we will keep the specimen in the oven for a period of 24 hours. So when you keep it for a period of 24 hours, what happens to the specimen is all the water in the specimen will be evaporated. So we'll get only weight of, so whatever weight you are getting, that weight indicates weight of solids. So oven dry weight is 1.75 Newton. Oven dry weight is 1.75 5 Newton. And this weight is nothing but it is weight of solids, because when you are keeping the specimen in oven, all the water is getting evaporated. So oven dry weight is nothing but weight of solids. Next, specific gravity of soil solids is 2.7. Okay, question: which experiment do you conduct to find out specific gravity? Which experiment is conducted to find specific gravity of soils? Anyone? Which experiment is conducted to find specific gravity of soils? Pycnometer and density bottle or glass bottle. Okay, next. What was the total volume of the original undisturbed specimen, assuming specimen was 50% saturated? So degree of saturation is 50%. So S is equal to 50%. That is 0.5. Because we know the weight of solids and we have to find the volume of the total volume of the soil, I will make use of this formula. That is uh, dry unit weight of soil is given by weight of solids divided by volume of soil. Now we have to find volume of soil. So if we simplify this, volume of soil is equal to weight of solids divided by dry unit weight of soil. Now weight of solids is given, but we don't know what is the value of dry unit weight. So we have to calculate the value of dry unit weight. Dry unit weight is so next, to calculate dry unit weight, we'll make use of this expression. G into gamma W divided by 1 plus. Now we know what is the value of G. It is 2.7, and gamma W is, it is a constant. Its value is 9.81 kilonewton per meter cube. But we do not know the value of E. E is unknown, so we have to find the value of. Now to find the value of E, we have to make use of this expression. E into S is equal to W into G. So E will be given by W into G divided by S. Now we have to find E. We know what is the value of G. It is 2.7, and in the question S is given as 50%. S is 50% here. So S is 0.5. G is 2.7, S is zero point 0.5, but we don't know what is the value of W. So W value is unknown. So we have to find out W. How do I find W? They have conducted oven drying method experiment. So in my oven drying method experiment, what is W? It is weight of water divided by weight of solids. Weight of solids is given, it is 1.75 Newton, but weight of water is not given, but we can calculate weight of water. Weight of water is equal to this weight minus this weight. The first weight minus second weight will give you weight of water. Total weight of the soil minus weight of solids will give me weight of water. So now you can calculate water content. So please calculate and tell what is the water content. Water content is weight of water divided by weight of solids. Weight of water is total weight of soil minus weight of solids. So total weight is 2.1. Weight of solids is 1.75. Please tell me what is the answer. Anyone?
3.
How much?
0.2.
0.2.
So water content is 0.2. Okay, now substitute this water content in this equation. E is equal to W into G divided by S. Now we know what is the value of W. It is 0.2. So 0.2 into 2.7 divided by S. What is the value of E?
1.08.
W is 0.2, G is 2.7, and S is 0.5. So E will be equal to
8. 1.08.
1.08. Now substitute this value of E in this equation. Value of G is 2.7. Unit weight of water is 9.81, and value of E is, we have calculated it as 1.08. So tell me what is the unit
12.73.
12.73.
12.73. What is the unit?
Kilonewton per hour.
This is 9.81 kilonewton per meter cube. So here also it will be 9.81 kilonewton per meter cube. Okay. So now we have dry unit weight. Now substitute the value of dry unit weight here and find the volume. Volume of solids is, weight of solids is 1.75. And dry density is
0.1.
okay. Weight of solids is 1.75 Newton and dry density is 12.73 kilonewton per meter cube. So what is the volume?
0.1374.
How much?
0.1374.
0.13.
74.
Okay, 0.137. What is the unit? Volume. What is the unit of volume?
Meter cube, sir.
Okay, but here the weight is in Newton and this unit weight is in kilonewton. Weight is in Newton, unit weight is in kilonewton. You can't substitute values in different units. You will get wrong answer. So you have to convert this kilonewton into Newton per meter cube. So I will multiply by 10 raised to 3, that is 1000. So what is my answer?
137.47.
0.137 into
10 raised to
minus 3 meter cube. Newton and Newton will get cancelled and we will get answer in meter cube. Newton and this Newton will get cancelled and we'll get answer in meter cube. Oh, so this is the question and answer is 0.137 into 10 raised to minus 3 meter cube. We'll move to next problem. Okay, next problem. Please write this down. The maximum and minimum dry unit weights of sand. The maximum and minimum dry unit weights of sand determined in the laboratory are 21 kilonewton per meter cube and 16 kilonewton per meter cube, respectively. If the relative density of sand is 60%, determine the in situ porosity of sand deposit. The maximum and minimum densities of soil is 21 and 16 kilonewton per meter cube, and relative density of sand is 60%. We have to determine in situ porosity of sand deposit. Uh, Relative density is given by this equation. Relative density is given by this equation. Gamma d max divided by gamma d minus gamma d minimum, gamma d max minus gamma d minimum. Now gamma d max is 21, gamma d minimum is 16, and dr is relative density. Relative density is 60%, that is 0.6. Gamma d max is 21, gamma d minimum is 16. So substitute all the values and simplify to get the value of gamma d. So you can find the value of gamma d. Next, after you find the value of gamma d, find the value of porosity. We have used this equation many times. E is equal to G into gamma W divided by gamma D minus 1. You will get value of Voigt's ratio, and then substitute this Voigt's ratio in this expression. N is porosity. Porosity is equal to Voigt's ratio divided by 1 plus Voigt's ratio. So you can find porosity. This is a very simple substitution problem. Please, please try this simplification on your own and see if you
Sir,
can find the
show the
value of gamma. What?
show the question once more, sir.
In the question, maximum and minimum dry unit weights of sand are determined in laboratory, which is 21 kilonewton per meter cube, 16 kilonewton per meter cube. Relative density of sand is 60%. We have to determine in situ porosity of the sand. Porosity is denoted by N. So this is the formula for relative density. In this formula or in this expression, relative density is known, it is 0.6. Gamma D max is 21, gamma D minimum is 16. Substitute all the values and find the value of gamma D. Okay, gamma D value is 18.67. It is calculated as 18.67. After you get this value, substitute this value of gamma D in this expression or formula. In this formula, G is given. The value of G is 2.65. The value of G is 2.65, and gamma W is constant. Its value is 9.81, and gamma D is calculated here using this equation. So substitute all the values, you will get value of E as 0.78. Next, substitute this value of E in this expression. N is equal to E divided by 1 plus E. You will get the value of N, porosity. Try to do this simplification on your own and find the value of gamma D. I will go to next problem. This is a very simple problem, sixth problem. Please refer the PDF later and solve it. This is the last problem. We'll solve this and we'll wind up this class. Okay, we'll solve this one now. Please write down this problem. After you solve this problem, take a photograph of all the problems solved today and upload it to the Teams within half an hour. Okay, so we'll solve the last problem. For a soil in its natural state, for a soil in its natural state, Void's ratio, water content, and specific gravity are 0.8, 24%, and 2.68 respectively. Void's ratio is 0.8, water content is 24%, and specific gravity is 2.68. Determine bulk density, dry density, and degree of saturation. Full stop. If the soil is completely saturated by adding water, what would be its water content and saturated density? So there are two parts of this problem. In the first part, Void's ratio, water content, and specific gravity are given, and you have to find bulk density, dry density, and you have to find degree of saturation. So we'll do the first part now. First, write down the given data. So Void's ratio is 0.8. Next, water content is 24%. Write it in decimals. 24% will be 24 divided by 100.24. And specific gravity is 2.64. Sorry, 2.68. So this is given in the question. We have to find bulk density, we have to find dry density or dry unit weight, and we have to find degree of saturation. This is a direct substitution problem. If you remember the expressions or the formulae, you can directly substitute the values and you can find bulk density, dry density, and degree of saturation. Now, if you remember bulk density, we have this equation. First, we'll solve for dry density. Okay, for dry density, we have this expression G into gamma W divided by 1 plus E. Okay, substitute all the values and find the value of gamma D. G is 2.68, gamma W is a constant 9.81, and Void's ratio is 0.8. Substitute all the values and tell me what is the value of gamma d.
Sir,
13.60.
14.660.
Okay,
14.60.
14.6.
13, sir.
30. It is not 13. It is 14. Please check your calculation. G is 2.68, gamma W is 9.81, E is equal to 0.8. So gamma D is 14.6. Now to find bulk density, we have this expression gamma D is equal to gamma B divided by 1 plus W. So W is known, gamma D is also known. You can easily find gamma B, that is bulk density. Take this denominator part to the numerator part. We will get 1 plus W into gamma D. So this is my. So what is the value of gamma B?
18.10. 18.10.
18.1.
18.11.
Okay, 18.1. And unit
18.88,
is,
sir.
huh? Unit is kilonewton per meter cube. Next, to find degree of saturation, we have this equation. Anyone, can you find degree of saturation? We have used that expression many times.
0.804.
Okay, value is correct, 0.804. We have this expression E into S equal to W into G. So S will be equal to W into G divided by E. So value of S is
0.79.
0.
79. 0.8.
Okay, 0.79 is also fine.
0.804.
0.8.
0.79, 0.804.
0.804.
But you have to write the value in percentage. In percentage, it will be, you have to multiply it by 100, you will get 80.4.
8.4.
So this was the first part of the question. In the second part of the question, you have to find, this is the first part. In the second part of the question, if the soil is completely saturated, when the soil is completely saturated, degree of saturation is 100%. What would be its water content and saturated density? Now, in my second part, I have completely saturated the water. So degree of saturation is 100%. or it is equal to 1. So when degree of saturation is equal to 1, he is asking what is the water content and what is the unit weight. That is bulk unit weight. So first I'll find water content. So again, soil is completely saturated by adding water. Now when you add water, my question, when you add water, voids ratio will change or will it be constant? Voids ratio will change or will it remain constant? When water is added, voids ratio will change or will it remain constant?
It will change, sir. Change, sir.
What is voids ratio? It is volume of voids divided by volume of solids. So to change voids ratio, either you have to change volume of voids or either you have to change volume of solids. You cannot change volume of solids. Volume of voids. Now when you are adding water, how the volume of voids will change? You are filling the voids with water. Yes. When you add water, that added water will come and fill the voids. When it fills the void, will it change the volume of voids? Yes or no? Voids are empty spaces. When you are adding water to those empty spaces, the volume of that empty space, will it remain constant or will it change? It will remain constant. You are just filling that space with water. You are not changing the volume of that space. So when you add water to the soil, the volume of the voids will not change. It will be constant, and hence voids ratio will also be same. It won't change. So degree of saturation is, no matter how much it is, if it is 80% or if it is 100%, your voids ratio will always be same. It will be 0.8. Understood? Voids ratio will not change if you add water. It will remain same. So voids ratio is 0.8 and specific gravity is also constant. So find the value of W. Use the same relation. So W will be equal to E into S divided by G. E is 0.8, S is 1 and G is 2.68. So what is the value of W?
0.29. 0.298.
It is 0.298. So water content is 0.298. In terms of percentage,
29.
29.8. Okay. Next, we have to find the unit weight, bulk unit weight. When soil is 100% saturated, bulk unit weight can also be called as saturated unit weight. So gamma B will be equal to gamma SAT. So let's find gamma B. We can again use this equation. Gamma B is equal to 1 plus W into gamma D. Gamma D will be same no matter what is your uh, dry density. Gamma D will be always same. So substitute gamma B is equal to 1 plus W into gamma D. W is 0.298 and gamma D is 14.6. Gamma D is 14.6 and W is point
58.1.
how much?
58.
18.95.
18.95.
Okay, it is 18.95.
Sir, 18.95.
Okay, 18.95 unit.
Kilonewton per meter cube.
Kilonewton per meter cube. So this is the problem. Uh, there are some 10 problems. Okay, nine problems in the PDF. Try to solve it. And send me back the photographs. Okay. Eighth problem, write down the question, solve it on your own. I'll give you 10 minutes. If there are any doubts, please ask. I'll be there for 10 minutes. Please try to solve this on your own. In its natural condition, a soil sample has a mass of 22.9 Newton, volume 1.15 into 10 raised to minus 3 meter cube. After being completely dried in the oven, sample weighs 20.35 Newton. Find bulk density, water content, voids ratio, porosity, degree of saturation. Okay, don't find this air content, just dry density. Bulk density, water content, voids ratio, porosity, degree of saturation, and dry density. There are only three values in the data. First is mass of soil sample 22.9 and it has a volume of 1.15 into 10 raised to minus 3 meter cube. Now this volume sample is kept in the oven and it is dried. And after drying, they will again take the weight which is 20.35. Now this oven dry weight, the water will be evaporated, so it is weight of solids. So you have weight of soil, volume of soil, and weight of solids, WS. If you have any doubt, please ask. It is a very simple question.
Sir, sir, the weight of solids in natural conditions ತಗೋಬೇಕೇನ್ರಿ ಓನ್ ರೈಡ್ ತಗೋಬೇಕು
ವೇಟ್ ಆಫ್
ಸಾಲಿಡ್ಸ್
ಹಾ
ನ್ಯಾಚುರಲ್ ಸ್ಟೇಟ್ ಒಳಗಿನ ತಗೋಬೇಕೇನ್ ಸರ್ ಏನು ಓನ್ ಸ್ಯಾಂಪಲ್
ಅದನ್ನು ನೀ ಓವನ್ದಾಗ ಇಡ್ತೀಯಲ್ಲ ಸಾಯಿಲ್ ಫಸ್ಟ್ ಸಾಯಿಲ್ ಇರ್ತದ ಸಾಯಿಲ್ ಇನ್ ವೇಟ್ ತಗೋತಿ 22.9 ನ್ಯೂಟನ್ ಇರ್ತೈತ ಅದು. ಈಗ ಈ ಸಾಯಿಲ್ ಸ್ಯಾಂಪಲ್ದಾಗ ಸಾಯಿಲ್ ಸಾಲಿಡ್ಸ್ ಇರ್ತಾವ ನೀರು ಇರ್ತೈತಿ ವಾಟರ್ ಇರ್ತೈತಿ ಹಾ ಆಮೇಲೆ ಈ ಸಾಯಿಲ್ ಸ್ಯಾಂಪಲ್ ನೀ ಓವನ್ದಾಗ ಇಡ್ತೀವಿ ಓವನ್ದಾಗ ಇಟ್ಟು ಡ್ರೈ ಮಾಡ್ತಿ ನೀ ಓವನ್ದಾಗ ಡ್ರೈ ಮಾಡಿದಾಗ ಏನಾಗ್ತೈತಿ ವಾಟರ್ ಇವ್ಯಾಪರೇಟ್ ಆಗ್ಬಿಡ್ತೈತಿ
ಎಸ್ ಸರ್
ವಾಟರ್ ಇವ್ಯಾಪರೇಟ್ ಆದ್ಮೇಲೆ ಮತ್ತೆ ನೀವು ವೇಟ್ ತಗೋತಿ ಅದೆಷ್ಟು ಇರ್ತದ ವೇಟ್ 20.35 ನ್ಯೂಟನ್ ಸೊ ಇದೇನ್ ವೇಟ್ ಇರ್ತೈತಲ್ಲ ಒನ್ ಮೇಲೆ ಇಟ್ಟ ಮೇಲೆ ಏನ್ ವೇಟ್ ತಗೋತಿಲ್ಲ ಅದು ವೇಟ್ ಆಫ್ ಸಾಲಿಡ್ಸ್ ವಾಟರ್ ಇವ್ಯಾಪರೇಟ್ ಆಗಿರ್ತದೆ Okay, one data is missing from the PDF. You have to assume G is equal to 2.7. Okay, anyone with the answers? So I'll solve the problem now. Okay. Water content is given by weight of water divided by weight of solids. Now, weight of water is given by total weight of the soil minus weight of solids.
Water
What is
content
water?
12.5%.
Water content is 12.
12.5%.
Okay,
5%.
water 12.5%. Correct. Bulk density, it is direct substitution. Weight of soil is 22.9.
19.9 Newton per meter cube.
Okay, 22.9 divided by 1.15.
Mm,
19.9 kilonewton per
meter cube.
meter cube. Bulk density is 19 point.
Sir, 0.125.
Water content 0.125. Bulk density 19.91. Correct. W is 22.9.
Sir, why?
In a W,
Sir,
W is 22.9.
why
Volume is 1.
ratio 0.4?
In a, I don't know. Either this is in Newton.
Why 4?
Okay. This 10 raised to minus 3, which is in the denominator, when it comes to numerator, it will become 10 raised to 3. Howda?
Yes.
10 raised to 3 in itla, it becomes kilo. So density you will get in kilonewton per meter cube. Weight is in Newton, but it is 19.91 into 10 raised to 3. So I will write it as 19.91 kilonewton per meter cube. Understood? I'm getting my answer as 19.91 into 10 raised to 3. I'll make that 10 raised to 3 as I'll take that 10 raised to 3 as kilo, and I'll write it in terms of kilonewton per meter
Yes,
cube. Understood? Same
yes,
thing
sir.
goes with dry density. 20.35 divided by 1.15. 17.69. So if you find the value of E, G is 2.7 and gamma W is 9.81. Gamma D is 17.69 minus 1. Void's ratio is 0.49.
497.
Finally, degree of saturation. Water content is 0.125,
67.9.
G is 2.7 and E is 0.49. So 0.16 or 16%. 0.165 or it is equal to 16.5%. Have you understood or do you have any doubts? Please, because this is the most important module in your syllabus this semester as well as next semester when you have second part of the GT. All these equations you have to remember this semester as well as next semester because you will be using it in your next semester also. Not just remember it, you have to understand it. What happens to the volume of voids when you add water? What happens to voids ratio when degree of saturation increases? So on. This is very important concept. So please, if you have any doubts, ask or at least